Good afternoon. I am Christine van der Merwe. I come from Senekal in the Eastern Free State, and I'm going to teach you something about shape measurement and space this afternoon, especially perimeter, area, volume, and surface area. The shapes that we are going to talk about this afternoon is the square. Now the square is a shape where all sides have the same length. They sometimes call it S, they sometimes call it L, but the sides have the same length. That is the important thing. Then we're also going to look at the rectangle. A rectangle is a shape where the length is the long side and the breadth is the short side of the shape. It's important that you must remember the length is always the long side. We're also going to look at triangles. Now, what is a triangle? It is a shape that has 3 sides and 3 angles. We have different triangles: acute, obtuse, and right-angle triangles, equilateral triangles, isosceles, and scalene. But the important thing that we're going to do this afternoon is the triangle that has one angle which is 90 degrees, and this is the right angle triangle. 570 years before the birth of Jesus Christ, there lived a man, Pythagoras, and he was fascinated by the triangle. Pythagoras found something very interesting. As they were having fields along the Nile River, they saw something that was very, very peculiar to him. Remember, we said we are handling the right angle triangle now, and that is the angle that has one angle of 90 degrees. Now, the theorem of Pythagoras says, in any right angle triangle, the square on the hypotenuse is equal to the sum of the squares of the other 2 sides. Now, I have this funny picture of a little man that can help you to remember this theorem of Pythagoras. The blue triangle tells you this is a right angle triangle. The 2 stands for the square. The line there says the hypotenuse, and it's equal to the sum, that is the plus sign, and the 2 legs with the 2 shoes on is the squares on the other 2 sides. I'm going to repeat this. In any right angle triangle, the square on the hypotenuse is equal to the sum of the squares of the other 2 sides. Now, what does this mean? They had fields along the Nile River, and that's our piece of the field or the Nile River there. And they found out that the field of Mr. Green and the field of Mr. Yellow was exactly the same as the field of Mr. Brown. Mr. Brown's field is situated on the hypotenuse. So what do we do when we work with the theorem of Pythagoras? First important thing, it must be a right angle triangle. It must have one angle of 90 degrees. When you square the one side and get that whole field of Mr. Green, and you square the other side, you get that whole square, that field of Mr. Yellow, and you add those 2, it will be exactly the same as the whole field of Mr. Brown. Now you must remember, if I just want the length of that side of the hypotenuse, I have to square it to Mr. Green's line. I'm going to repeat that. The field of Mr. Green plus the field of Mr. Yellow is exactly the same as the field of Mr. Brown. Now sometimes they also ask you, they give you Mr. Brown, they give you Mr. Yellow, and they want Mr. Green. So now you can see that's the small one. Then we have to square them, square the line for Mr. Brown, square the line for Mr. Yellow, and subtract the 2 to get the field for Mr. Green. I'm going to repeat the theorem of Pythagoras once again. In any right angle triangle, the square on the hypotenuse is equal to the sum of the squares of the other two lines. Then we also have a circle. Remember, the diameter of a circle is one radius plus another radius will give you the diameter. The radius goes from the center to the end of the circle, and that's the radius. So sometimes they give you a formula where they use the diameter, but sometimes they also give you the formula where they use 2 times radius. It's exactly the same thing. So radius times 2 is the same as diameter. Then we see that some people have a problem with radius square. What does it mean if I talk about radius square? That means you have to multiply the radius by itself. So if the radius is 15, then you have to say it's 15 times 15. This is quite a common error that we find when we mark the papers, that learners do not know that radius square is the radius times the radius. So for instance, when you want the area of a circle, it's pi radius square, so it's 3,14 times 5 times 5, and not times 5 times 2. So make sure that you use the correct notation there. Remember the circle, the diameter, and the radius. Now something concerning the formulas. All formulas will be given to you. Make sure that you use the correct formula and that you substitute correctly. It is very, very important to remember the units. Now when we work with perimeter, we use kilometers, meters, centimeters or millimeters. Perimeter is normally used when I want, for instance, the line around a swimming pool. When I put fencing around a swimming pool, or I put quarter rounds around the classroom. That is what perimeter is, and we measure it in meters. When we go to area, the units will be kilometers square, or meters square, centimeters square, and millimeters square. Area is 2-dimensional. And the area, when I talk about the area of the classroom, for instance, that I will use that when I want to lay a carpet in my classroom. Then think about what does a piece of carpet look like? And that is meter square. If I want 15 square meters of carpet in my class, it means that I will have 15 blocks of carpet that I will lay into my class. Now the volume. The unit for volume is 3-dimensional, and here I must have a 3-dimensional object. Volume is measured in kilometers to the power of 3 or cubic kilometers, meters to the power of 3 or cubic meters, centimeters to the power of 3 or millimeters to the power of 3. Please remember that when we work with volume, we work with 3-dimensional objects. I am going to show you some 3-dimensional objects now. This box of matches is a 3-dimensional object. What is the difference between a 2-dimensional and a 3-dimensional object? A 3-dimensional object, you cannot see all the sides when you look at it. Can you see? You cannot see the bottom side of this box of matches. This is a rectangular prism, and we will determine the volume of this box of matches. Here I have a cube. As you can see, a cube, all the sides are the same, but it is a 3-dimensional object, and we will determine the volume of this cube later on. Then I also have a cylinder. This is a cylinder. The base is a circle and it has height, but it's 3-dimensional because you cannot see the bottom part of this cylinder now. And then I have a very nice one, my favorite, a Toblerone chocolate. This is a triangular prism. It is three-dimensional because when I hold it like this, you cannot see the bottom part. So these four are the objects or the shapes that we're going to do this afternoon: the cube, the rectangular prism, cylinder, and a triangular prism. Let's just recap on the different sides that we had, or the units that we had. For perimeter, we used kilometers or meters, area, two-dimensional, meter square, volume, three-dimensional, so it's meters to the power of 3, and now the last one, the surface area. As the word tells us, surface area is two-dimensional. We want to know, when we want to know how this shape was put about, if I want to unfold it or I want the net of this object, I want the area of that object. And that is the area is kilometers to the power of 2. We will come back to that later on this afternoon. Now let's start with perimeter. When we work with perimeter, the unit that we use again is either kilometers, meters, centimeters, or millimeters. Now when I want the perimeter of a square, where all sides are the same, it's side plus side plus side plus side, or 4 times the side if you want to. Then we go to the perimeter of a rectangle. It's L, the long side, plus B plus L plus B. Or then if you want to, 2 times L plus 2 times B, or bracket 2 bracket L plus B. But let's think about it in the easy way. L plus B plus L plus B. When I want the perimeter of a triangle, I want to know what is the length of the side that goes around it. It's side 1 plus side 2 plus side 3. When we talk about a circle, we use the word circumference. It's exactly the same as perimeter, but for circle we use circumference. And we get that by 2 times pi times radius, or then pi times diameter. Let's quickly recap on the perimeters. The perimeter of the square is side plus side plus side plus side. The rectangle, L plus B plus L plus B. The perimeter of a triangle, side 1 plus side 2 plus side 3. And the circumference of the circle, pi times diameter. Now sometimes they give you a shape that you cannot classify it as a square or a rectangle. It's a compound shape. And then we use the same idea that we have now. You're just going to add all the sides together to get the perimeter of that compound shape. We will have a look at one of those examples later. Now the area, we are nearly there. So then we're going to start doing some problems. So just in a few minutes we're going to be finished with this. The unit for area is kilometer square, meter square, centimeter square, or millimeter square. The area of a square is side times side. The area of a rectangle is length times breadth. The area of a triangle, half base times the perpendicular height. And immediately when I see a triangle, I remember that man, Pythagoras. The area of a circle, pi times radius, or pi radius square. Let's quickly recap. The area, we use the unit of kilometer square or meter square or centimeter square. And the area of a square is side times side. The rectangle, L times B. the triangle half base times perpendicular height, and then the area of a circle is pi times radius times radius. Something that's very important that you must remember is that you will get the formula for all these problems. All the formulas will be given to you. Just make sure that you write it down correctly, that you do not make a mistake when you write the formula down. That is a common error that we find when we mark the grade 12 papers. Make sure you write it down correctly, and then when you substitute it correctly. We are going to do a few problems, and I want you to have a look in your workbook. We are doing the second workbook now, and we are on page 1. In this workbook, you must choose the correct formula where applicable from the following list. Round the answers off to 2 decimals and use pi is equal to 3,14 unless stated otherwise. Round answers off to 2 decimals. Please make sure that you round it off to 2 decimals. But also be on the lookout. Sometimes they ask you to round it off to 1 decimal. Then you must make sure that you round it off to 1 decimal. Sometimes they ask of you to round off to the nearest whole number. And a whole number is a number without a comma and something after the comma. So then it must be a natural number. Make sure that your rounding is correct, because that is one of the places where we penalize when we mark the papers. We have looked at all these formulas, and we will get back to them later on. I just want to show the last one there, the good man Pythagoras. A square is equal to b square plus c square. Can you remember? We had Mr. Brown, Mr. Green, and Mr. Yellow. We will get back to the Theorem of Pythagoras. Let's go to the first one there. The first problem that you have, the perimeter and area. We are going to calculate the circumference and the area of a circular flower bed with a diameter of 2,5 meters. Immediately, I see a red light going on. Diameter of 2,5. This tells me here is a problem. Diameter of 2,5. So what is the first thing that you must think of? You must remember the radius is going to be what now? Diameter is the whole distance. If you look at the circle, the diameter goes from this side through to that side. So the radius will be half of that diameter. The diameter 2,5, so if I want the radius, it will be 2,5 divided by 2, and that will give me 1,25. Another red light that you must look for is when I have a problem with different units. In this problem, we don't have different units, we only work with meters, as you can see. Now we're going to do the circumference of this flower bed. The circumference is given by the formula 2 pi radius. Alright, we do 2, you know what 2 is, you know what pi is. It's 3,14 throughout your whole exam paper. So you have 3,14. But what must I do now with the 2 and the pi and the radius? I am not going to add them. I am going to multiply them. Please, if these things are standing next to each other, they are so close together, they are kissing each other. And if you write a love letter and you want a kiss, to send your loved one a kiss, you will write the kisses there. And that means multiply. So you're going to say 2 times, and I don't use pi, I use 3,14. And what am I going to do with the radius? It's also standing next to it, times the radius. Can you remember we had the radius 1,25, and the answer there is 7,85. Can you remember what we said about what did we say about the unit for perimeter and circumference? It is meters. Now we learned a lot of things now. We learned that we have to change diameter to radius if we want to use this formula. So you must first calculate the radius. We know that pi is 3,14. That is given on the first page of your exam paper. It is given to you. But the most important thing that we learned now is that we saw that 2 pi radius means 2 times pi times radius. Please, learners, you must not add these numbers. You must multiply them. They are standing next to each other and they are kissing each other. Will you please remember this? All right. Now when we do the area of this flower bed, the area is given by the formula pi radius square. Red light. Square, remember square means radius times radius. Pi is 3,14 times, can you remember, they are standing next to each other. The radius, we did the calculation of the radius there, as you saw, 1,25. So in the place of radius, I fill in 1,25. And if you have a calculator that has a square sign on it, you can put the square sign on there. Otherwise, you can just go times another 1,25. And the answer there is 4,90625. Red light. I'm seeing a red light. I have to round. I have to round. To how many places? I must round to 2 decimal places after the comma. Now when we round, it's important that you must look. If I want to round this one, you just look for this one, the closest one. So you will round this off to 4,91. And the unit is meters square. Let's repeat this one. We started with a formula, pi radius square, and we said it's 3,14 times 1,25 times 1,25, and the answer was 4,90625. Red light, you must round. And we round to 2 decimals in this case because it was not stated otherwise, and the answer then will be 4,91 meters square. Now we learned some important things on this page. Let's just recap this question. The circumference of the circle, when we calculate it, we need the radius. If they give us the diameter, you cannot work with the diameter. You must change that. Change that diameter to radius by dividing it by 2, and you get the 1,25. And then you go on and you work with 1,25. So it's 2 times 3,14 times 1,25. And you get the answer. Another red light. Make sure you have the unit. Otherwise, you will be penalized if you do not give us the unit. Circumference, we use meters. Then for the area, we get the formula, pi radius square. So you go 3,14 times the radius, and when you get an answer with a lot of places after the comma, 4,90625, you just look at the 6. And the 6 will lift this one step higher, so it will be 4,91 meters square. Red light, your unit. The red lights on this page will be the radius if they give the diameter. It will be using the multiplication signs, the unit, the radius square, which means radius times radius, the rounding, and the unit again. Now we go on to question number 2. In question number 2, they give you a shape and they say calculate the perimeter and the area of the trapezium. Now we do not have the formula for that, especially for the perimeter. This is a shape that we do not have the perimeter. And now it's a compound figure. So we will have to use something else to help us to calculate this. This is 1,6 meters. They give us this one is 160 centimeters. And we know that you have to convert this to meters. This one is 2,5 meters. And that one is 1,8 meters. And this one is missing. There is nothing there. So we will have to make a plan to get the length of that side. Now what do you see here if you have a look at this shape there? This is a triangle. And now we remember that good man, Mr. Pythagoras. Mr. Pythagoras gave us a good way to find out what the hypotenuse is. Alright, let's have a look at the triangle further, or the trapezium. This length here is 1,8. From there to there is 1,8 meters. This whole length is 2,5. So can you see, if I take it down here, what will be the length of that part? This one at the top and this one are both 1,8. Now if the whole line there is 2,5 and that part is 1,8, how will I get the other part? It's the long one minus that one will give me this part. And if I subtract 2,5 minus 1,8, I get 0,7. So the length of this part here is 0,7. Now it looks very complicated, but it is actually so easy because we are going to tackle this problem like you would eat an elephant. Do you know how we eat an elephant? We eat it bit by bit. So we're going to take this. The first thing here is this rectangle. And now we're going to look at this triangle. Now how will we determine this side? Let's call it X, or call it A, or call it hypotenuse, anything that you want to. If I want to calculate what is the length of this side, I know that this is 0,7 and that one is 1,6, so this is also 1,6. So let's quickly draw this triangle. I'm going to get a separate piece of paper to just take out this triangle that we have there. This is 0,7. That one is 1,6. And can you see everything is in meters now? And I want this one. So if I get the square on this one, on this side, and the square on that side, it will be equal to the square on this side. How do we write it? x squared is equal to 1,6 squared plus 0,7 squared. And that will give me 0,49 plus, no, sorry, this one's 2,56 plus 0,49, and that gives me 3,05. So this is the x squared. X squared is 3,05. What do I do when I want x? Then I must get the square root of 3,05, and that gives me 1,7464. Red light. I must round. So let's round this to 2 decimal places. What am I going to do? I'm going to look at the first one after this, 4. The first number there is a 6. So the 6 is so important, it will lift that up to 1,75. And now we can write the unit 1,75 meter. Let's go back to our sketch. This x is going to be 1,75 meters. Alright, what did we do now? We used the theorem of Pythagoras to determine the length of the hypotenuse of that right-angled triangle. This is a right-angled triangle. And how did we do that? We said x squared is equal to 1,6 squared plus 0,7 squared, and that gave me 2,56 plus 0,49, and it's 3,05. But now 3,05 is this whole area here, the whole square. So to get the length of this side, I must square it back. And this is something that learners forget to do. You get that 3,05 and you work with that, and that's not right. Please remember that the answer that we get here is the whole square, so we must square root it back, and the answer then 1,75. Let's get back to the original sketch that we had. We now determined that this is 1,75. If I now want the perimeter of this figure, it will be, let's add all the sides together. That one is 1,8 plus, that one is 1,6 plus, this whole one there is 2,5, and that one is 1,75. If I add that, I get 7,65 meters. Perimeter is measured in meters. So what did we do now to calculate this perimeter? We first had to convert that 160 centimeters to 1,6 meters. So that when we start with this problem, everything must be in meters. Then this line here was 2,5 meters, that one was 1,75 meters, and that one was 1,8 meters. I added them all, and the answer for the perimeter there was 7,65 meters. If I now want the area of this trapezium, the formula that is given to us is a half bracket A plus B times the height, where A and B are the sides that are parallel. So what do? When we work with a half, there is another easy way to work with a half. We use the decimal number. And what is the decimal number for a half? If you want to determine that on your calculator, and you have the fraction 1/2, equals. What does it say? It says a half. That helps us nothing. But we have this magic key that says SD. And now it gives you the decimal. Now it gives you 0,5. So with this SD, you can go from fraction to decimal number. So instead of a half, you can use 0,5. Now what is happening between a half and the bracket? Brackets mean we are going to multiply. So we multiply. What is the length of A? If I can just refer back, that length will be 1,8 plus B, this side here, was 2,5. And the height of this one was 1,6. If it says nothing, it means multiply. If it says nothing, it means multiply. So put in those multiplication signs, otherwise sometimes it tells you that there's an error. And the answer that you get there is 3,44 meters square. Right, let's recap what we have done now. We got the figure of a trapezium. Not all the sides were given. We did not get the length of this hypotenuse. So we had to use the theorem of Pythagoras. We used the theorem of Pythagoras by squaring these two sides, adding them together, and getting the square root of that. That gave us 1,75. We had to square them, add them, square root them back, and round it. So there were quite a lot of calculations that we had to do there. So we got 1,75 for the hypotenuse. 1,75 here, plus 1,8, plus 1,6, plus 2,5, and that gave me the perimeter. So if I have a swimming pool that looks like this trapezium, and I want to put fencing around it, how many meters of fencing will I need? I will need 7,65 meters of fencing to put around my swimming pool. That is perimeter. When I want to calculate the area of my swimming pool, that means I want to put tiles on the floor of my swimming pool. Then I use the formula half A plus B times H. Half is, the decimal for a half is 0,5 times 1,8 plus 2,5, the two parallel sides of the trapezium, those two, times the height of the trapezium, and that gave me 3,44 meters square. Number 3. A 2-meter path is built around a circular lawn with a diameter of 20 meters. Red lights. I see the red light of the word diameter. Can you remember what we said about diameter? We must immediately do the radius. So if the diameter is 20, the radius will be 10 meters. Now you must also remember, this is our lawn. This is the lawn, this green part here. And I want to put a path around it. Now the length of the path is 2 meters. Can you see there it says 2 meters. And we have to calculate the area of the path. Again, we're going to do it as we eat an elephant. Let's start with the area of the big circle. That big circle. The area of the big circle is pi, and the radius, let's take a big radius, big R, square. pi, I think you can remember that by now, is 3,14 times the big radius now. Now, if you look at this, we said the small radius is 10. But now I also have that part, which is 2 meters. So can you tell me what is the radius of the big circle? It's not 10. It's not 2. It's this whole length from there throughout, because we are looking at the big circle now. So the radius of the big circle will be 10 plus 2, which is 12 square. Or then 12 times 12. And the answer there is 452,16 meters square. The area of the small circle, now I ignore the path around this part. We're just going to look at this blue circle now. And I want the area of that one. The area of the small circle, again, by radius square. 3,14 times, what is the radius of the small circle? From there to there is 10. 10 square. And the answer there is 314 meters square. Now I want the area of the path. In other words, this part must be thrown away. So I will cut it out. I will throw it away. So what will happen? I'm going to take the area of the big circle minus the area of the small circle, and that will give me 452,16 minus 314, and the answer is 138,16 meters square. Now I want the learners to just have a look here. When I work out these problems, I do not use the units, because we sometimes find that you get confused when there's a meters there and there's a square and you don't know what to square. We rather leave out the units there and only write the units when we give the answers, so that you do not get confused when we have squares in the sum. You will lose no marks if it's like this, but remember, at the end of the answer, you must have meters square. Let's quickly recap this one. A 2-meter path is built around this lawn, and then we had the red light of diameter 20, so radius is 10. So we calculated the area of the big circle was pi times 12 square. Then the area of the smaller circle was pi times 10 square. And then we subtracted the 2 because I wanted to cut that out. If I had a scissor now, I would cut this out and throw it away, because I just want the path. I don't want this part. That's why I said the big area minus the small area. And the answer there, 138,16 meters square. Number 4. Determine the perimeter and the area of the garden shown in the diagram. Again, I can just see I'm eating an elephant here. We're going to do it bit by bit. When I want the perimeter, I'm going to add up all the sides. This is 12 plus 12. I want to put fencing around, plus 5. Oh, but yes, something is missing. So how will I get the length of that side? Now, if you look at this one, this is 18 from there to there. This is 12 from there to there. So the 12 is from here to there is 12. So how long is that? If this is 12, that's 18. This will be 6. So that one will also be 6. So you will have to say 18 minus 12 will give me that 6. And exactly the same with the other side. I don't have the length of that, but I do have the length of this green side. This is 12. That part is 5. 12 minus this 5 is going to give me 7. So this one is 7. And now I can do the perimeter. So the perimeter will be 12 plus 7 plus 6 plus 5 plus 6 plus 12 plus 12. And the total there is going to be 60 meters. Perimeter, the unit for perimeter is meters. Remember, perimeter is meters, area is meters square. You will not get the formula for a shape like this. They will not give you a formula because they expect from you to know that all sides must be added. So don't wait or don't think it was forgotten. They will not give you the formula. You must remember, to get the perimeter, you will just add all the sides together. Now to do the area of this figure. The area of the grass or the area of this part. The best way is to do it as you eat an elephant. Let's start with this part. Let's call that block A. So I want the area of this block. This is a rectangle. So let's call that block A. It's L times B is the formula for a rectangle, the area of a rectangle. And that is 12 times 12. And it gives me 144 meters square. The area of B. Now B, let's do B in red. B is this small block there. It's 6, B. Let's call that B. This side is 6, 5, 6 and 5. So the area will be L times B. The long side is 6. The short side is 5. And the answer there will be 30. Now, as you can see, to get the total area, I will have to add these two. I will say A plus B. So A plus B is equal to 144 plus 30. And that gives me 174 meters square. Let's quickly recap on this. The first one, we did the perimeter. We had to deduct these two from each other to get that length that they didn't give us. Then we added all the sides together to give us the perimeter. To calculate the area, we broke it down into two parts, part A and part B. We got the area of that rectangle was L times B. And it gave me 12 times 12, which was 144. To get the area of that is 6 times 7. 6 times 7, and that's 6 times 5, and that is 30. So it will give me 174, the final answer. Now we get to a very interesting exercise. The exercise of the vision high. They want to paint the inside walls of the classroom. The diagrams, not shown on scale, of the 4 walls are shown below. As you can see, we have the northern wall, the western wall, southern wall, and the eastern wall. Then they also give us all the formulas. You will see the formula or the dimension. The dimensions, the windows are 1,100 millimeters, 800 millimeters. Immediately I see a red light because here we work with millimeters, there's meters. So we must convert. before you start working on the sum, you must convert to the same. Let's convert to meters. We convert by dividing by 1,000. So it will be 1,1 meters times 800 millimeters. 800 divided by 1,000 is 0,8 meters. The door is 2,4 meters and 0,8 meters. The chalkboard they give us and the pinboard. They want to paint the walls, the door, the 7 windows and the chalkboard, and the pinboard will not be painted. Then they give us an example. They said to paint the northern wall, how would they do that? They took the whole area of the wall, it's 10 times 3, and they minus 1, 2, 3, 4 windows. 4 windows and the sizes of the windows, we got it here, 1,1 times 0,8, and then we get 26,48. And now they said we must calculate all the walls now in exactly the same manner. So let's start with the southern wall. Again, as you can see, we do it as we eat an elephant. When we do the southern wall, the first thing that we're going to do for the area is the wall minus 1, 2, 3 windows minus the door, because we're not going to paint the wall, the windows and the door. So it will be 10 times 3, the area of a rectangle, 10 times 3 minus 3 times the windows are 1,1 times 0,8 minus the door 2,4 times 0,8, and that gives me 25,44 square meters. Then we go over to the western wall. In the western wall, we have the chalkboard. So to get the area, you must calculate the wall minus the board, the chalkboard. To get the wall, you will go 6 times 3 minus the chalkboard will be 4,5 times 1,5. It was given earlier, and the answer there will be 11,25 square meters. We go over to the eastern wall. We will do the area of the eastern wall, the wall minus the pinboard. The wall will be 6 times 3 minus the pinboard is 4 times 0,8, and that gives me 14,8 square meters. Now they want us to give the area of the whole, the total area. So we have to add all of them. Where did we get the first one as an example? We got it as an example. In the first one, the northern wall, north plus east plus south plus west. The northern wall was done for us, and it was 26,48 plus the eastern wall, was 14,8 plus the southern wall 25,44 plus the western wall 11,25, and the total area 77,97. Remember, this is area, so it is meters square. The last thing that I want to do is they want to work out how much paint they're going to use. And I've got a very special way of doing this. 1 liter of PVA paint will cover 6 square meters. How many liters of paint will be needed for the area that we are going to paint? Can you remember what was the total? It was 77,97 square meters that we want to paint. Now, when we have a ratio like this, we can put it in a block and we can do cross multiplication like that. There are different ways of doing this. This is just one of the ways that we can do that. And when we do the multiplication across, I will get 6 times x is equal to 1 times 77,97. Remove the 6 by dividing it, divide with the 6, and the answer then will be 12,995 liters. It is impossible to buy 12,995 liters. We must round it. And round it to the nearest whole number will be 13 liters of paint. So we round it up to the nearest whole. It's important that when we work with paint, we must round up. Otherwise, there will be a part of your wall that has not been painted, and we don't want that. Cross multiplication, when there's a ratio like this, do the multiplication 6 times x, 1 times 77,97, and divide with a 6. We are going to have a short break of 10 minutes, and we'll be back after 10 minutes.